Hi there, it's Ruth, and today we'll be looking at exponent rules. And these types of expressions will take the form of a base or a number that is being multiplied by itself. And it will have an exponent, which will tell us the number of times this number will be multiplied by itself. So if we see an expression with 5 raised to the power of 4, this is telling us that the number 5 will be multiplied by itself 4 times. So if we were to expand that expression, it will be 5 times 5 times 5 times 5. And we see that 5 is being multiplied by itself 4 times. Similarly, if you see 4 raised to the power of 5, what this tells us is that 4 is being multiplied but to itself 5 times. So we'll take the form of 4 times 4 times 4. So essentially we see that 4 is being multiplied by itself 5 times. All right, so the first rule we'll be looking at is the product of powers. And this tells us that if we have two exponents of the same base, and in this case, the base is a, if we have two exponents of the same base and they're being multiplied, we should add the powers. So in this example, one power is m, and the other is n. So we'll be adding the powers. I'll use an example to better explain. We have 2 to the 4th power multiplied 2 by 2 to the 3rd power. Essentially, we're saying the answer should be 2 to the 4 plus 3. 4 plus 3 is 7, so it'll be 2 to the 7th power. And we could look at this in a different way. 2 to the 4th power is 2 times 2 times 2 times 2, which will be 2 2s 4, 4 2s 8, 8 2s 16. And 2 to the 3rd is 2 times 2 times 2, which will be 8. So if we have 2 to the 4th multiplied by 2 to the 3rd, essentially we'll be multiplying 16 by 8. 6 8 is 48. 8 1's 8 plus 4, 128. And if we look at it, let's expand now 2 to the 7th. 2 to the 7th power should be 2 times 2 times 2. That's 3, 4, 5, 6, 7. And let's look at it. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 32, 64, 128. So this confirms the product of powers, that if we're essentially multiplying two exponents of the same base, all we need to do is add the powers. All right, the second rule is the quotient of powers, and this tells us that if we have two exponents of the same base and they're being divided, we just subtract the powers. Again, 2 to the 4th divided by 2 to the 3rd. Essentially, we just need to subtract the powers. So 4 minus 3 is 1 or 2. 2 to the 1st power or 2. And again, we could look at this. If we expand the expression where we have our 2 times 2 times 2 times 2, and that's divided by our 2 times 2 times 2, we can see that, okay, we have 2 to the 3rd power is in a denominator, so we could cancel out that which is in the numerator, and we'll be essentially left with 2 or 2 to the 1st power, which is 2. And again, this is another way of confirming the quotient of powers. All right, so the third rule we'll be looking at is the power of a power. And basically it says if we're raising a power to a power, we multiply the exponents. So for example, if we have 2 to the 3rd power and we're raising that to the 4th power, we must essentially multiply the exponents. So 2 to the 3rd power raised to the 4th power will be 2 to the 12th power, because 3 times 4 is equal to 12. All right. The fourth rule is the power of a product. And Basically, it's saying that if we're raising anything in parentheses by a power, everything in parentheses must be raised to that power. For example, let's say we have 2x and all that is going to be raised to the fourth power. This essentially will become 2 to the fourth power and x to the fourth power. And we know that 2 to the fourth power is 2 times 2 times 2 times 2, which gives us 4, 8, 16. So this essentially is 16x raised to the fourth power. Next rule we'll be looking at is the power of the quotient, and it tells us that if we have a number that's being divided or even a fraction and we raise that fraction to a certain power, we must raise both the numerator and the denominator to that power. Let's take 2/3 and raise that to the fifth power. So basically we're saying the 2 should be raised to the fifth power and the 3 should also be raised to the fifth power. And if we expand it, because we're multiplying 2 5 times and 3 5 times also. 2 raised to the fifth power is 4, 8, 16, 32. And 3 raised to the fifth is 9, 27, 81, 243. So 2/3 raised to the fifth power is 32 over 243 because 2 raised to the fifth power is 32 and 3 raised to the fifth power is 243. And the zero exponent tells us that any number or variable raised to the power of 0 is 1. So a raised to the power of 0 is 1. 2 raised to the power of 0 is 1. 3 raised to the power of 0 is also. And to the final rule for this slide, we have the negative exponent. And basically it's saying that if we have a negative exponent, if we take the reciprocal of that negative exponent, we remove the negative sign, or we make that exponent positive by taking the reciprocal of it. So let's say b raised to the negative 2 is equivalent to 1 over b squared, or b to the second power, or 5 raised to negative third is equivalent to 1 over 5 raised to the third power. Again, thank you so much for watching, and please feel free to leave comments of questions you're working on, and I'll be happy to assist in arriving at the correct answer. Thank you again. Take care.